Cool. Thanks, Tony. Thanks, Stacy. It's a bit smaller one than usual, so I really want this to be kind of a collaborative sort of thing. If you guys have any questions midway, just stick your hand up. It's fine. Because I'm going to talk a little bit about the two different systems, why you might want to choose one or the other, what the differences are, and then a little bit about how you can gradually introduce types into existing or new applications and start taking advantage of this kind of thing. But if you guys have questions, just feel free to pipe up, seriously. I deliberately put less content in here than normal, so that we could go over things a little bit more in depth, or if people have questions, we can handle it. So we'll have the time, so don't feel bad. So anyway, my name's Sam, Sam Reed. I'm a local developer, moved here from Hong Kong. I grew up in Manitowoc, the land of Stephen Avery, so don't worry. Been a front-end developer for 10 years, did some other stuff before that. Been doing it for a while. And I'm CTO and co-founder of BitMEX, Bitcoin Mercantile Exchange. We do leverage derivatives on Bitcoin and altcoins and all sorts of irresponsible things. So let's talk about dynamic languages. Oh, and actually, before I do, just to know, we use Babel and Flow in production at BitMEX, and we've had a really great experience with it, which is why I'm talking about it. So dynamic languages. So how often have you seen something like this? If it's a little small, zoom in, but a function signature like that. What the hell is a spline? What the hell are the options? How are you supposed to know? If they haven't documented it, how do you know? How do you know what this thing's supposed to use? How do you know when it changes? How do you know how to use it? How do you know what it returns? Common problem. Common problem people have all the time. And a couple of frameworks were built up to address this kind of thing. A couple of projects, JSDoc, Google Closure Compiler, eventually TypeScript Flow. But it's a really common problem in dynamic languages. If the language itself was not built for the ground up to explain this sort of thing to you and to be statically typed from the beginning, it's kind of a constant guessing game. It's bad with JavaScript, it could be bad with Python, it's bad with Ruby, you all end up in the same problem. What the hell is this variable and what can I do with it? And will somebody please catch me when I use it wrong? That would be really great. So one kind of crazy thing about JavaScript that people sometimes criticize is the weird coercion mechanics of it. Have you ever seen that talk called WAT? Where the guy talks about all the weird stuff that JavaScript outputs. There's a couple of examples of the string coercion kind of getting a little out of control, and the number coercion because the plus operator is overloaded in all sorts of weird and interesting ways, and depending on where something is in a given comparison, or sorry, in a given operation, it might call toString, it might call value of. If you don't know these things, right off the bat, you might get this kind of feeling, which is just, what the hell is this thing doing? And if I put a variable, for instance, that I know to be a number, I know to be a string, and I put it in the wrong position, and for instance, the addition operator, I've got a different type coming out of it, and I didn't know that. It can screw up all kinds of things in my code. And to be honest, this is something, that's really distracting. This is something that it really hints back to kind of the original design of JavaScript in 1995 when Brendan Eich made it. You guys probably heard the story that Brendan Eich wrote JavaScript in all of about 10 days. And the original goal was, as he said, to make the monkey dance. It was a scripting language for animating parts of your website. It was never meant to be a general application language. And in fact, you can see in the design that it's pretty much built to keep on going at all costs. If you screw something up, it's just going to keep on trucking, because it's better to give you a wrong value in JavaScript parlance to do something surprising than to stop executing an error. And this is something we see throughout the design of the language. PHP has the same problem in that it becomes very difficult to use it for serious applications because of all these weird rules, because people used to just design little tiny personal websites with it, And it's not made for what we're doing with it now, but here we are, you know. Nobody, I think, wanted JavaScript to be the general web application framework, to be the only language you can reliably use on the web, but it is. And we just have to deal with that. So, as I was explaining to you guys earlier, what's really great that we can really benefit now from is that you've got all these big Silicon Valley companies out there who are willing to put in a large amount of time, a large amount of effort, and a lot of really talented developers into making tools that can make this stuff suck less. It can help you make applications that actually work, that are actually predictable, that don't do such ridiculous things, and they're willing to give it away because they want to recruit more developers. Now, if you don't want to work for Facebook or Microsoft or Google, that's fine. You can just use the project, and you should, and you absolutely should, because if the type checker isn't doing it for you, you've got to do it yourself. But one way or the other, you're still going to end up doing it. So any kind of automated process you can get into your application, it's worth doing. So I say, why type your applications? Well, everyone's doing it is actually not true at all. Not many people are doing it, and they really should, because you get predictability, you get reliability, you get the ability to refactor with confidence, you get the ability to do all these things that you could do in better languages, but you haven't been able to do with JavaScript until now. I would honestly say that typing is at least as important as testing, if not more so. If you're trying to, if you're testing your app, if you're really into testing, I think the thing to ask yourself is what's the real goal? What are you actually trying to accomplish, for instance, by testing your app? Well, you want to be sure that you ship fewer bugs to production. It's the number one thing, right? You don't want people emailing you. You don't want your boss calling you saying, hey, this is broken, why the hell is it broken, why can't you do your job, etc. You don't want customers getting kicked out of your login and register process. You don't want fatal bugs in production. Nobody wants that. And a lot of people write tests for this process, and you should. You absolutely should, to try things front to back. But you can catch a lot of things earlier, and you can catch a lot of things that you didn't know were bugs with types. When we converted BitMEX over to Flow, I caught a bunch of front-end bugs I didn't know existed. You can get slightly the wrong value, or various, modal various pages would fail under certain conditions that I just had no idea existed. And they're the kind of bugs that you would never even think of. And testing, can never prove the absence of bugs. Testing can only prove the absence of some of the bugs that you know about. So we need to use every tool at our disposal to help with that kind of thing. So with typing, you get great easy development. You get IntelliSense if you use Microsoft tools. If you're using other things like Sublime Text Add-on, whatever, you can still get the same kind of autofill, kind of auto type signature lookup, documentation lookup, all that kind of thing. It's really great. It's kind of like many of you guys that you've done, Java development, C# development, et cetera. It's obviously super handy. Talk about that. And number one thing is, the computer's development especially should be something that's sort of like a force multiplier. You want to do as little work as you possibly can. So if there's ever a chance to make the computer work for you, you need to do it. So anyway, I'm gonna breeze real quick through some of the history of some of these problems. Can you guys read this okay? Yeah, I use Sublime Text only because I can't stand Atom. I really like Atom and I really like the idea, but I open a lot of large files and it just won't have it, and I don't want to be switching between editors. Sublime Text has pretty good integration. It's not fantastic. It can autofill some things and make some mistakes. One thing it does do really well is practically immediate type checking, and that as you're typing, say, a variable, you're going to get it highlighted as you're typing, essentially until you spell it right, until you use it right, which is great. It's great to get that 300 millisecond feedback instead of feedback on save, for instance. So Nuclide, which is Facebook's big development package that they build on top of Atom, does better flow analysis, but it's also quite a bit slower, actually, and it's a little clunky, and they shipped some show-stopping bugs lately that really mystified me. But overall, the whole thing is improving rapidly. I mean, every every 3 months it seems like there's a major release that just massively expands the power of these tools. So it's really kind of a matter of time. I mean, all these products are built on platforms that didn't even exist 2-3 years ago. It's kind of mind-blowing. One of you guys have a question?
I was going to say TypeScript is supported.
TypeScript tooling is great. It's much better than Flux. So anyway, I hope you guys can read this because it's kind of green on green. Change it. Yeah, whatever. So years ago, 2009, ancient history in JavaScript standards, not ancient history by any other standard. There were a lot of projects that tried to address this kind of problem. And if you wrote JavaScript years ago, you probably saw a whole lot of these kind of things above every kind of method. You annotate the this parameter, you annotate the individual parameters, you annotate the return type, you might annotate something like read-only or abstract or public-private. There were all kinds of crazy extensions to these things. And the Google Closure compiler actually did a relatively decent job of making sure that the comments were at least somewhat in line with the real code, and it would do some rudimentary type checking. I was talking with a couple of people about it earlier. I'm not quite sure why Google Closure never really caught on. Part of it, I believe, was because it was such a pain to integrate with existing products. It was kind of more like a platform than, say, just a type checker. And it had really inscrutable documentation in classic Google style. But this was the state of the art basically until 2012, when TypeScript was open source. This was the best you were going to get in JavaScript, unless you're doing, say, GWT or any of the other Google projects that just simply used a better language for web development. So let's talk a little bit about things that types catch. Changes break applications. This is a really simple piece of code right here. There's not a whole lot going on, but it's something you might do. Imagine you have a web application. User first signs on. You're going to say hello to them, right? Well, there's a lot of kind of deeper, more technical things that might go into that, but this, as it sits, is a really simple piece of code. But there's a million ways that this thing can go wrong. For instance, let's look at, let's say somebody refactors the user model for some reason. Maybe they capitalize the N in name. Maybe they choose that they want to support users from all over the globe, and there's just a name attribute instead of a first name, last name. Well, how many times have you seen something like, hi, undefined, undefined? I feel like probably everyone's seen that at some point in a JavaScript application. Another product, for instance, of JavaScript being used to make the monkey dance. If you access a property on an object that doesn't exist, nothing happens. You just get undefined coming out of it. So you've got to have something else to catch it. Maybe in the future you want to say, do something like, I want to look up what this user's seen before, make sure they haven't seen the same notification twice. You know, you don't want to greet the user, say, hey, welcome, more than once. So you're going to require an ID. Well, you're not passing an ID to this thing, and when you access, say, options.id on the show mobile function, you're going to get undefined. You're not going to get an error. This is an easy bug. So get a little bit of this feeling. Because if you really think about it, honestly, you got about 5 lines of code here, and you could go on and on and on and on about all the ways it could break. That's how I feel every day. So we're going to talk a little bit about how you might fix something like that. So this is really cool, by the way. So Flow is written in OCaml, and there's a great OCaml.js compiler called JS of OCaml. And long story short, you made it with a code mirror editor, and you can do live type checking demonstrations in the browser. TypeScript has something similar as well. So let me get a little bit more on there. You guys read it okay? Yeah. So this is the same code sample as you might write it in Flow, and to do it in TypeScript would be very similar. You define, say, a user schemata. Now, a user might have a lot more properties than this. It's a simple example. But you could even auto-populate that, say, directly from your database if you wanted to. I I have a project, there's a couple others I've seen around. Really, you just need a way to populate templates in order to do it, but you could say theoretically pull that schema down from your database and populate those types automatically. And then anytime, say you use a user in your application, you can be sure that all the properties you access on it actually exist and are of the right type, and anytime a change happens, your application will start throwing type errors, which is exactly what you want. You want type errors all the time. You want as many type errors as you can get. So let's think about, that first little refactoring that you might do. Somebody decides, hey, we're more of a camel case kind of organization, right? Look at that, we got immediate type errors out of there, and Flow's going to tell you exactly where the bad access was and what you did. So you can imagine in a scenario where you're automatically linking your schemata back to the application, that's what you'd immediately see. And hopefully whatever continuous integration tool you're using would yell at you and break the build and so on. So let's say, we're not, well, let's go with it, let's fix the type errors. So it's pretty simple. Actually, you get a nice little hover type over there, and you get that kind of hover in Nuclide, in Atom, not so much in Sublime Text. Please.
So are you, some of the stuff from like stylistic, like case and whatever, are
Yeah.
you using all this in conjunction with something like ESLint or some sort of linter too?
Yeah, you would use it with a linter as well, but a linter wouldn't catch this kind of thing. I mean, you might have a rule like, hey, all variables should be camel case, and it would catch, that versus underscore or something like that. But, let's take maybe the more likely refactoring, which is that, you decided to internationalize your app, and you're not going to do first name, last name anymore. So you're going to come down here and think, all right, well, this is a serious problem. So every single place you use a user, and every single place you're accessing first name is going to error, and you're going to have to go in there and fix it and unbreak your build. But this is great. Now you're not finding and replacing all over your application. Your build is broken until you actually fix this. And then say the other strategy you might do is, let's say we want to get the user ID in here, so we can track which modals have been used by which users. So right now we got an error actually saying that you didn't supply the user ID. So I'm going to go put the user ID in. I'm going to say, put an M in that column. I'm going to say, hey, that's cool, but you don't actually have an ID on the user because your type definition sucks. So I'll say ID is a number. Cool, good to go. And somebody else goes around and migrates your database and says, you know what, we don't really want to tell people how many users we have. We don't want to use sequential IDs, so we're going to use GUIDs. So now ID is a string, and your app's broken again. And you've got exact feedback of exactly what's wrong, so that if this mobile function right here is relying on user ID being a number for whatever reason, and it might be, you've got immediate feedback. Really, really, really great stuff. So this might be a little fast. You might see some syntax you haven't seen before. For instance, like the type definitions and things like that. I'll get into that in a little bit. I just want to give you guys kind of a real quick overview of some common bugs that we catch. Another really nice thing, and this speaks really well to integrating an existing product. This is an example of code that has no annotations whatsoever. So Flow doesn't require you to actually put annotations on your code. It can infer various ways that you're using variables in your application to be sure that they should be a certain type. So they've typed out all the major Node APIs, most of the major browser APIs, so they're all set with types. So if you use any of those and you pass the wrong type of data to it, it's going to yell at you. But it can even look at your individual code and say, all right, you can't multiply a string times 10. I can't zoom in anymore, so you guys just have to deal with it. And it's even pretty smart. This is parsing the code and parsing the ASD, so you can't trick it with stupid stuff. So you can't do, say, return the X, and then, okay, now I'm passing it. Sorry. Well, I wrote identify, but I meant identity, but you have to go with it. It goes through the function, and it still knows that return type, or that this input type, even though it's gone through 2 functions now, is supposed to be a number. It knows what it is as it flows through the application. And it also knows that, say, if I fix this type error, and I do 1, 2, 3, 4, right? Now I've got no type errors. Well, it knows that the return type here, when I multiply it, has to be a number. There's no other thing it could be. So if I try to call some sort of string function on the output, it's going to say, hey, what the hell? So this is really great. This is a great example of how you can just turn flow on an existing code that you already have and start catching these kinds of bugs without doing any sort of type annotation. If I do type annotations, I can add them on after the fact. I might get slightly better output. Now it's going to tell me right here that the type error is here instead of inside the function, but the result is essentially the same. So let's talk a little bit about what it requires to actually kind of put one of these things together. Because this will really get to why TypeScript and Flow are so different and why you might want to use one over the other. So if, say, you wanted to implement your own type system, what do you actually need to do? The most obvious thing probably is explicit type annotations. The most basic type systems require some sort of annotations if we assume no inference whatsoever. And in order to do that requires some sort of syntax adjustment. Either you're doing it via comments, which Google Closure did, or you basically invent your own language, like TypeScript did. And then once you get a little bit better, you can trace control flow. You can start inferring types on your own, which is really great. One thing Flow does really helpfully for you is it can tell you if it can't properly infer the type of something. And you can configure it such that it'll throw an error when it does that, but the rest of the time it won't require you to actually annotate something. So if you've done a lot of Java or C# work, for instance, you might feel a little bit like this, typing in the type for every single variable you ever use. And there's some JVM languages, for instance, that have auto types, and maybe Java 8 has it or something. I don't know. I've been out of that ecosystem for a little while, but it's not necessary to type absolutely everything all the time. The type system can figure a lot of this stuff out and reduce the work that you need to do. But anyway, any type system is going to need some way of typing external libraries using Lodash, jQuery, React, etc. You want to be able to trace the flow of data through those libraries. You want to be able to have an ecosystem of people who are contributing these definitions. You want to be able to download definitions, say, in an NPM package and be able to get strong types for all those libraries you use. And of course, like I mentioned before, if you're using annotations as a new syntax, you need a way to strip those out so that the code runs. No JavaScript engine is going to run the code that I had a couple examples ago because the syntax is all out of whack. There's no type syntax, obviously, in JavaScript. So if you're going to do something like this, you have to have a way to convert it back to vanilla JavaScript. So now we get kind of to the meat of what I think you guys hoped I would eventually cover, which is why you might choose one over the other. And we'll talk a little bit about TypeScript. Now, TypeScript is a compiler and a type checker. In order to inject types into JavaScript, they decided they're going to build their own language. And this, honestly, at the time it was built, was a really good idea. TypeScript was originally built in 2010 internally inside Microsoft. It wasn't open source until 2012. Back in 2010, we had nowhere near the kind of system we have now. We didn't have, say, ES6 classes at all. I don't believe that was even a proposal in 2010. So the Microsoft team built TypeScript to basically be a front-end version of C#. And they added classes, they added private and public methods, they added abstract classes, they added interfaces, they had all these things there. It simply got to the point where you couldn't just strip the types out. You had to have a whole new language, and that's fine. You run it through the compiler, but that has certain disadvantages. It's not JavaScript; it has different semantics. You have to really kind of bind this ecosystem to use it. Like I mentioned, it's written in TypeScript. Sorry, no, I didn't mention this. TypeScript is written in TypeScript. That's pretty cool. This is kind of a classic, you ever heard the term self-hosting? A lot of languages do this. You get to a certain point with the development of the language where you can write the next version of the language in the language itself. So I believe around TypeScript 07, I might be making that up, they rewrote it for 0.8 in TypeScript. So TypeScript 08 is built with 07, TypeScript 09 is built with 08. A lot of languages do this. Rust does this, C does this. A lot of people do this. It's a great way to kind of dog food and to make sure that the developer experience is all right, to make sure that you're able to do the things that you need to do with the language. Okay, so on the other hand, we have Flow. Now, Flow is just a type checker. And in my opinion, this is what gives it a lot of its strength in that we're all about lowering the bar to entry to get this into as many applications as you possibly can. So think of Flow a lot more like ESLint. It doesn't require any code changes right off the bat to integrate it. It's just another way that you're statically analyzing the code that you already have. So if you're running any sort of large JS project, you're probably already using ESLint or JSLint. You might be using JSCS, although JSCS is merging into ESLint. And you should be using Flow for the same reason, just to give yourself more assurance. Use it like a linter, so it's easier to integrate. You can write plain JavaScript with type annotations. And of course, it has a couple of these special keywords like declare and type, and it actually has an interface keyword that nobody knows how to use. But overall, it's mostly just JavaScript. There's a Babel transform called Babel plugin flow strip types. There's two plugins, one that understands the syntax and the other one that strips the types out. And it's actually pretty simple. It's just all a matter of identifying the type, the flow-related nodes in the AST and just getting rid of them in order to compile it down to regular JavaScript. And if you don't already use Babel, and a lot of projects don't already use Babel, you can use annotations like comments. So you can do that, and Flow can read that, and that's totally 100% valid JavaScript, and now you're typing things. So that is pretty sweet if you're not willing to buy into Babel just yet, which of course a lot of projects aren't. Flow is written in OCaml at Facebook. Now Camel used to stand for Categorical Abstract Machine Language. So OCaml is just objective camel. They dropped the acronym, so now it's just a camel. But it's a really cool language. It's worth checking out if you're really into you know the more computer science side of really cool programming languages. So why is TypeScript a compiler? I got into this a little bit before because I rambled, but 2012 was originally hosted on CodeFlex. It had been in development for 2 years before that at Microsoft. They squashed all the commit history, probably all kinds of junk in there. Moved it to GitHub like everybody else in 2014, and they've had really active, really vibrant development since then. So it predates Babel by 4 years, and before Babel there were a lot of EST parsers. Babel itself is built on the Acorn parser. There was I forget what Tracer used. There's been a lot of these, but they wrote their own from scratch. They needed a compiler to do the type annotations. Flow itself was made in late 2014. The first commits you see in there. They obviously had been developing it for some time inside Facebook. It's not quite clear how long. They wrote a bunch of documentation for a while and then just shipped a whole ton of OCaml. But they were able to take advantage of a radically different JS ecosystem. Between 2010 and 2014, everything changed in so many ways. So the first release was just a month after Babel. You might remember around there, Babel used to be called 6.5. Little known fact, Sebastian McKenzie, the main author of Babel, was currently in high school in Australia, 17 when he wrote Babel. Yeah, no kidding. And actually, he says, interesting part about it, one of the reasons that I think we've seen so much uptake with it was that Babel was originally designed to just transform your code in a way that was as unintrusive as possible. So you could look at your old code, you could look at your new code, and you could really easily see the relationships between the two. Unlike, say, Google's Tracer, which would do horrible, unimaginable things to your code, and it'd be so difficult to translate one to the other. So at that time, source maps weren't as good as they were today. So you could find yourself stepping through generated code. It happens all the time, still happens today. So it was really nice, especially when Babel first came out, to be able to step through it and understand it. He's since then actually said that that was a ridiculous goal, and as any sort of transpiler or compiler, whatever you want to call it, becomes sufficiently complex, you have to give up that goal because it gets to be too much. If you've ever done Babel with like async await, for instance, and the generator conversions, you have one line of code turn into about 12, and you lose the context. But when it originally came out, it relied on React tools. So Flow was part of the React ecosystem from the very, very beginning. And I believe developed either by the same team or guys who were very close to that team. And they switched to Babel in 2015. It was actually kind of controversial when they first put the JSX transformer into Babel. A lot of people thought that Babel and 6.5 should just be about ES6. It shouldn't be about all kinds of weird random crap, especially not big bad Facebook random crap. But they came around and realized that it would just be so incredibly useful that they're going to do it anyway. And I believe eventually TypeScript came around to that in like 1.7 or 1.8, that they were going to finally do TSX, which is just JSX for TypeScript. I remember a lot of discussions about why the hell do we need JSX, but it's here to stay. So when they moved off React tools, if you have some older React projects, you might still have the old React tools code in there. It's just a really simple AST transformer with a couple of rules. It's pretty cool though. So you might notice I'm talking a whole lot about Flow, and a big part of that is because I use it in production, so I have a lot more interfacing with it on a daily basis, and I'm continually impressed with the quality of the releases they put out and how many of my stupid mistakes it catches on a regular basis. And I wouldn't have even considered using TypeScript before then, basically before this release. TypeScript 2.0 was a really, really, really big release. And it's the kind of thing that actually makes this question, Flow versus TypeScript, a little muddier. Before 2.0, I'd say Flow without reservation. Now it's hard to say. One big thing they've helped work on quite a bit is the JS interop. They're working on that same story of how do I put TypeScript into an existing application, because obviously a lot of code is already out there, a lot of it's already written. You don't want to start from scratch rewriting file by file. So they finally made it so you could import JS as JS and not have to rename the extension or do any sort of nonsense conversions. They introduced a really nice shorthand declare module syntax so you can just kind of real quickly type the exports out of a module so you get some semblance of type information out of it. The big one was nullable types. TypeScript up until 2.0 actually had no concept of null, which is a bad idea in a lot of ways. You imagine, say, a function takes in a number. If the number's over 10, it returns a string, otherwise it returns null, right? Well, the output of that in TypeScript up until 2.0 was string. And you would go and you would manipulate that object as if it were, or that variable as if it were a string. And obviously half the time it's not a string. So it could be very, very unsound. They finally fixed that. You have to opt into it with a flag. I highly suggest you do if you use TypeScript. It's absolutely vital. They added control flow analysis. Can infer a lot more from your existing code. This is really cool. Get it? This types for functions. If you ever did any Python programming, for instance, you might know on a Python class, the first parameter to member functions is self. That's actually really great and really explicit and really nice. JavaScript doesn't have that, but if you think about it, honestly, this is always a parameter to every function. You just can't see it, but it's there. So the way they type it is really nice. It's just the first parameter in a function. If the first parameter name in a function is this, you can type it, and the compiler actually wipes it away. I'll get into that a little bit later. They've got tag unions, basically kind of big enums of objects. So you might have a couple different objects of different shapes going into a function. You might have a way of distinguishing one from the other, basically refining the type, and it can hold on to that type information and use it as it goes down. They got read-only properties. Those are super cool. Not a lot of people are doing that kind of writable false stuff with object-defined properties, but you can do it with TypeScript. And they've got a real weird one, which I included just because I think it's fun, the never type. The never type is the type that never gets returned. You think, what the hell is that? It's not void, it's not null, it's not undefined, it's never. Now, never means that the function never returns. And the only way a function never returns is if it throws an error. And that's actually kind of a cool thing to be able to type. A function that, given a certain set of parameters, perhaps, or just, for instance, might even be a wrapper around throwing some kind of error, never returns. And you can actually enforce that. So if you're ever actually relying on that thing returning, you're going to get an error. Now, that doesn't exist in Flow, but you can actually simulate it by creating the type string and number, the and being an intersection type. Intersection means essentially that it needs to satisfy both types simultaneously. Now, nothing can be both a string and a number, hopefully. So you can use that as a way to simulate a never type from a thrown function. So that's pretty cool. Pretty cool. I don't believe TypeScript, maybe Tony, you know, does TypeScript have the question mark syntax now for nullable types? This thing's a little.
I don't know. I haven't upgraded it through yet.
Okay. Yeah, this thing's a little onerous. In Flow and in Google Closure before that, you just put a question mark at the beginning of it. So it's like string. And that perfectly encapsulates what it is. Like, it might be a string, it might not. You better check. I'm going to talk a little bit more about TypeScript deficiencies. Just comparing to Flow, this is a related control flow analysis. Can't do switch stages, can't do async await, can't do object rest spread. If you guys aren't familiar with object rest spread, it's when you do like a dot, dot, dot in an object to copy an object or get the rest of the properties out of it. Kind of similar to the new array rest spread that you get in ES6. You can do like dot, dot, dot args in a function instead of having to munge the arguments object. Which, by the way, if you're not using that dot, dot, dot args in places where you're using arguments, you should. Because Babel's really, really smart about it. And you might not know that if you even look at the arguments object in the wrong way, you're going to cause de-optimization in V8, you know, in Node and in Chrome and in Opera and in Safari, and sometimes in Firefox. But if you do dot, dot, dot args with Babel, Babel does the right thing, which is create a little for loop to copy it over to an array, which is pretty much the only thing you can do to the arguments object that won't cause de-op. So if you want to deal with arguments like an array, you should be using that. Variance, I'll get into that. And the number one thing actually is access to the Babel ecosystem. And I think if anything's going to decide it for you, honestly, on one or the other, this might be it. And that TypeScript does not have a plugin infrastructure at all. So I'll give you an example. I'm neck deep right now in the middle of an internationalization effort with our application. We're launching in China. China's a big market for Bitcoin. And we have to tag every single string in the application and deal with plurals and deal with all the gnarly, terrible things about languages. If you ever internationalized any app, you know what I'm talking about. It sucks. There's a great library called ReactIntl that encapsulates messages in React components and then uses a Babel plugin to get the messages out. So you just write message objects in your application, and that automatically populates JSON files in a directory somewhere with the live messages that are actually in your code. If you change a message, it changes in the JSON. You delete a message, it's deleted in the JSON. So if you have some kind of sync mechanism between your project and translation agency, it's always up to date. You never have that issue with extra messages, out-of-date messages, and all that. Something you simply can't do, unfortunately, with TypeScript. You need to have an additional syntax transform to do something like that. There's other kinds of really cool projects out there. I've been playing with one called Tcone, which is great. It uses Flow syntax to do runtime type checks. So say you're running a development, Flow can't catch everything. JavaScript's a weird thing. The native JavaScript APIs, the types of those functions are a nightmare. The types of most functions are nightmares. I spent the better part of a week trying to type some backbone functions before I gave up. It's just, there's brutal types all over the place. Tcone is something that takes the same annotations and actually physically does the type checks at runtime in development. So if you get a bad result from an API somewhere, you just got a type that's too gnarly to statically analyze, you can do it at runtime in development. Having access to that kind of infrastructure is just fantastic. So I'm going to get real quick into control flow type analysis. This is really simple. This is a thing that both TypeScript and Flow will do for you automatically. If you do any of these kind of classical sort of type checks like this, type of x equals number, equals string, equals symbol, you do array.isArray, things like that, and it understands a certain number of functions that refine types. You can even write your own functions that refine types if you really want to. Something that, say, takes in any and returns an individual type. It then knows that the return type, or it knows that this variable right here at this point in time has to be a string, because if there were a number, it would have returned. That's super useful. Super, super, super useful. Get a little bit more involved here. The only difference between this is that I'm actually doing an assignment to x here, so now x is a number, but down here it could be a number or a boolean. It does all these great checks for you. It makes sure that you cover your bases, because you may be using your code responsibly, but someone else might not. So you got to cover all your bases all the time. I'm going to talk just real quick about type parameters. This is something you're going to see all the time using a type system. Like this, C# uses this. A lot of languages use this, or some form of this. It's really, really important stuff. The most basic type parameter in the world is the array. In Flow, an array is a type that accepts one parameter, and that parameter is what's in it. You can have an array of strings, you can have an array of strings or numbers. You can do all kinds of things with it. You can even say it's an array of any type. You can even do an array of star types, which is basically an indication of Flow that it should try to figure it out as best it can. And another, that has certain special uses. But the most interesting thing, I think, is that you don't even actually have to do that at all. Flow knows that this is an array of strings, because it's so obviously an array of strings. So if I try to cast it later to an array of numbers, it's going to error. If I try to access something that I want to be a number off of some strings, it's going to yell at me. It figured that out on its own, which is really great. When you might use type parameters is if you're declaring your own kind of type that does all sorts of things, and you can guess what kind of types come out of it, or you know what kind of types go out of it. In this case, I'm defining like a really simple data storage class. It just gets and sets, that's all it does. So we'll say it's just a map of strings, for instance. So, but it could be a map of numbers, it could be a map of dates, whatever. So I want to abstract that type away and just say that it's t. And I'm going to reuse that later. So it's a variable, essentially, inside your type system, using your type system as kind of a mini language. And I'll say, okay, this thing's got its own little data storage in it. So this is like this.data is an object. And this kind of looks like hell. This same syntax, I believe, in TypeScript. That's a way to say this is an object where all keys are strings and the values are t. I don't really like this syntax at all. So I always declare a global type in my projects called generic map. And I say that is equal to key string t. Right? So I'm basically saying it's just an object where the values are all of type t. So I can go ahead and change that out. Cool. Store. Now what I'm doing right here is just declaring the class. This is a mechanism in Flow. TypeScript has something similar where you're just saying these are the types of things in it. I'm actually writing the code for it. You can have declarations separate from the code, which is a really nice way to say, prototype out your APIs, to write all the types for them and then write the code later and make sure that everything makes sense. So I'm saying if you get something, a key, you get a t. You set something, you get with a string, you have a value, the value has to be t. You get void back, which is nothing. You could do something really weird and like chain it with this, like jQuery style chaining operators. Don't do that. So if I want to use it, it's pretty simple. I instantiate a map, and I'm saying this is a string map, right? So I can set foo bar, that totally works. It knows that anything I get from it, this const d, it knows that that's a string. If I try to tell it it's a number, it's going to yell at me. So it knows, it fully understands this class. It even understands this private data here if you want to access that for some reason. If I try to set something else to it, it's going to yell at me, etc. So you start with something like this. This is kind of the basics of how you type something that's a little bit more sophisticated to type. I'm going to get into this really quick. This is the part where your eyes glaze over. Oh, by the way, if any of you guys need some beers, it's not going to break my heart. I need one to get into this one. Seriously, yeah, thank you. All right. So this is a really interesting TypeScript issue, and something that I found is really cool with Flow, and I think it speaks to when the projects were made. And that TypeScript was made in 2010, Flow was made in 2014, Flow was written in OCaml. To even write OCaml, you need to have a fairly sophisticated knowledge of how type systems work. So they actually screwed this up pretty badly, and they're having some problems with this. We'll talk about invariance, covariance, and contravariance. You're actually going to run into this if you use type systems a lot. You might go, huh? What the hell is that? What the hell is contravariance? I know, I definitely was. Long story short, invariant means it's something that accepts only a given type, none of its super subtypes. So imagine, animals and cats and dogs and a whole hierarchy of living things and animals and cats, super and subtypes. Covariant accepts a type and subtype, so an animal is covariant to cat, and contravariant is the other way around. And where this applies to what we're actually doing here is when you start typing really sophisticated systems with type hierarchies. So for instance, arrays, if you put something into an array, it's covariant. If you have an array of animals, you can put subtypes into it. That makes sense, right? You can put cats and dogs in it, it's cool. You can add a snake, whatever the hell. They might not like it, but you can do it. Array getters, however, are contravariant. So this illustrates this point how this works. If you get something from an array, all right, so let's say I've got an array of cats, and it's got a kitten and a cat in it, and I get something out. I get out Garfield because he's not really a cat; he's more like a drawn monstrosity and a blight on the human race. We'll just call him an animal, and that's fine. I can type something out as a supertype, but I can't type something as a subtype. I know that this is an array of cats. I can't assume that something I get out of it is a kitten, is a subtype of that. That's a very important rule when dealing with arrays. If you violate it, your system is no longer type safe, and it can affect you in various and unexpected ways. So the issue, what happened with that? There we go. Loading the flow library takes a little bit. It's a lot of compiled OCaml. TypeScript treats all arrays as covariant. It assumes that you can always cast an array to a supertype. It's saying, okay, an array of cats is always an array of animals. And that almost sounds right. That kind of seems right in your brain. Like, yeah, obviously an array of cats is also an array of animals, but that's not true. Because you can't put a dog in a cat array, and if you cast an array of cats to an array of animals, you need to be prepared to accept the consequences of what that cast actually means. So in TypeScript, for instance, casting this array of snakes to an array of animals and adding a horse to it and trying to make that horse slither, A and B in this case are actually the same array, I've just aliased them, is perfectly valid code. In Flow, it understands that you can't do something like this, and it yells at you accordingly. Depending on your type hierarchies, depending on what you're doing in this application, this is something that could really bite you. Flow also now allows you to define type parameters with a plus or a minus to indicate whether or not it should be covariant or contravariant, the default being invariant. Very nice. You can do all sorts of really complex things. And this is kind of a quote from an article that I linked to in the comment. If you download the presentation later, you'll see the link, talking about how the basic architecture of TypeScript, unfortunately, doesn't seem to allow this sort of thing to actually be solved. Maybe they're planning a rewrite. I'm not quite sure. Okay, so I hope your eyes aren't totally glazed over. That's all I'm going to talk about variance. It sounds like a very niche thing, but it affects other parts of the type system, even with union and intersection types you might use all day long in various and unexpected ways. So it's important to get this right. So we can talk about this types. I talked about that real quick. This is the new TypeScript syntax for this types. Super sweet. You can say that callback that you assign something has no this. So if you try to do something bad with it, it's going to yell at you. Really great for your new developers who have just migrated over from jQuery apps and are always assuming that the this in an event handler is the element, and it's not. This is something you can use to catch those guys. Really nice addition. That and the non-nullable types are a really great way, really great reason, sorry, to migrate to TypeScript 2. And syntax differences, I touched this a little bit. This is the little number type thing that's pretty fun. In TypeScript, you've got type parameters like this. You're saying object.assign is a simple method that a lot of people use to copy the property of one object over onto another. So I'm saying copying everything that's on U onto T. So I'm saying that whatever's in T has to be at least as not, at least as much, if not more than U. In Flow, you would actually do it almost the same way, and this type checks in exactly the same way. But I'm saying that T is an object, and U is something that has the shape of T, meaning that it has some or all of the same properties, and those properties must be the same type. You'll notice actually it's approaching the same problem from different angles, but in the end, the result is exactly the same. You see errors on the same line right here. If you try to assign E to X and you have a defined shape to it. Very nice kind of error to have, depending on what you're doing. I'm going to get real quick into a little bit of real world here. Say you're running a Flux app. BitMEX is a Flux app, which is this, talked about it a couple of months back. It's basically just a data, God, what's the word I'm looking for? Essentially, it's just a way to architect apps such that you have a one-way data flow and you emit actions and you handle them in a mostly pure manner. One thing you always see a lot of times in Flux and Redux implementations is that they do something like have action constants. And if you look at this code, you kind of think like this feels a little dumb to be writing something like this. There's a lot of redundancy in it. So when I started out, I just didn't use constants at all because I found, in your actual code, you can still make the same kind of typos and they'll break in exactly the same kind of way, whether or not you use constants or not. Unless you have a type checker, in which case using constants are super sweet. So I was just using bare string. So I typed it in BitMEX like this. So Flow has this concept of all these nice little magic types. Basically, when something's in beta, it'll have a $sign behind it. Keys is something that's really simple. That's been, hidden for a year and a half. People use it all the time. It's in all kinds of official definitions. But basically, I'm saying that I want to emit an action, and an action is something that has the keys of this constant file right here. This could be instead something like, rather than an object, you could have a couple of files with like export const, and you could import that in as an object and say that it's the type of that. You could have more actions right here and say you have something else in there, and you could say, okay, this is the intersection of type of to-do actions and type of more actions. You could add as many of these things together as you want, and then you're going to get, too much. Then you're going to actually get real type errors when you screw this up. So for instance, common typo I make all the time when typing something like that, something about the left hand and the right hand, that's actually a typo, or sorry, a type error, and also a typo. And it's a really nice kind of error to get. And you can even go even further if you want to and say that dispatch, when it's called with this constant, accepts these parameters. It's called with a different constant, accepts different parameters, and basically define the function over and over again to make sure that even though it's a highly dynamic function that may accept any kind of thing at any time in usual JavaScript parlance, you can tightly type it and really prevent your jQuery developers from screwing up your app. External libraries, just real quick. Definitely type is the library repository for TypeScript. TypeScript has been around for a long. TypeScript definitely typed has 2017 definitions. It's one of the only repositories that I've seen that's so big it screws up GitHub and it can't actually list all the directories. That's kind of cool. A lot of these definitions are actually really good, really extensive. There's been a lot of back and forth. There's been a lot of development on these things. If you're using a lot of external libraries, this is a lifesaver. You can accurately track types as they flow through. Really weird libraries like low gas that do terrible things to your types. there's a lot of kind of niche libraries in there. There's a lot of good stuff. Float type is pretty much brand new and didn't even really work properly until a couple of months ago, so it's still really small. There's 114 definitions in there. Some of them are incomplete. Some of them work pretty well. There's a good bluebird definition in there for promises. There's a good Lodash definition. But it's nowhere near the quality of definitely typed. And people have basically been taking definitely typed definitions and converting them by hand into flow syntax. There have been people badgering Facebook for a long time to build something that will automatically do that. So we can take advantage of this huge wealth of type information that is just slightly different syntax and thus incompatible, which is really an infuriating thing. So if you open up one of these definitions, you're going to see something kind of like this. Because if you know, with like Lodash.find, this type definition might make sense to you. Takes in an array that's of a certain type. Predicate is an alias for a function that returns a Boolean and accepts something of a given type. So say you're iterating through an array with some kind of matcher. You want to find a given element in it. The parameter to that matcher is going to be of the same type as the things inside the array. And it's really nice to be able to succinctly type that. Which should I use? TypeScript, you value strong tooling integration. Are you starting a project from scratch? It's good reasons to use it. Or you want to take advantage of these much more mature type definitions. But you might want to use Flow if you have an existing project that you want to gradually type. You want to catch things right away, get something for nothing. If you're using React, the React support is a little bit better. If you want to use Babel now, if you want to use Babel later, you got to use Flow. And if you like camels, and especially OCamls, it's a really great reason to use Flow. It's a cool language, actually. Browsing the Flow source code is really fun. It's really interesting. But the point of all this, and I hope I've given you guys some clarity on it, is that no matter which one you choose, you should choose one because the barrier to entry has been getting smaller and smaller and smaller and smaller. And you can really get a lot of really interesting, really useful data out of your code using something like this. So to quote Shia LaBeouf, don't let your dreams be dreams. Just do it. I love him. All right, that's all I got. You guys got any questions? Hey, Stacey.
I have all questions for you. Do you ever, so there's dynamically typed variance, like, video down photo. Is there ever an instance where it was down on your left? And you wish?
Yes and no. You can always escape hatch with the any type, and you can just basically signal to Flow that you don't care and you don't want to be bothered about this thing. So that's really easy to do. I find myself, and maybe it's out of some sort of OCD or something, spending a lot of time on getting my type definitions working properly and making sure it's checking everything in the code because the front end, at least in the API servers on my particular project, are pretty much a one-man show. So I'm trying to do as much code as I possibly can, as reliably as I can, in as little time as I can. And I found that these type definitions, even when you put days or weeks into them, getting them really right and dealing with some of that nasty variance and type parameters and stuff, is worth it. Because you'll discover bugs you never knew you had, and it's really satisfying to close those up and to know that the type system is never going to allow you to make that mistake again, and that you'll get instant feedback on it. So, yeah, I guess the answer is kind of more no, because you have that instant escape hatch. Flow also has a separate mode you can put it in called loose mode, where it won't bother you about definitions that it can't figure out. It's really good for starting a project that's got all kinds of crap in it, and you want to really just be left alone unless you're doing something really obviously bad. It's really great. It's really great. Also, great at running your battery out. Flow is really good at that. It really efficiently multi-threads. It'll use all 8 threads, on a quad core easily. You might have heard of this concept of like the Flow server, and this is something I wish they just wouldn't even mention because it confuses people when they start out. I remember when I was starting out with Flow, I was like, what the hell do I do with the Flow server? Do I need to run files through it? Is it hosting files? What the hell is it doing? No, it's just literally caching type definitions in memory, because the first time you parse a large project, it might take 10, 15 seconds and pump up your cores and make the fan spin a little bit. But then the next time you query it, it takes 50 milliseconds because it's all sitting there in memory. So that really fast feedback that you get, as you're typing, even in a huge project, I mean, we've got, this app is so huge now, I don't know, 1,500 files or so, and it can still give me instant feedback as I type, because all those definitions are still in memory. So it's been really, really great that way. This TypeScript, is it able to cache things in memory? Yeah.
So they've gotten to the point where you can make changes in your app. They'll only run compilation on those pieces. So
Sure.
you don't even need to walk through the entire code base. Stop it and be like, yeah, you're good. Whereas like when I was a Mudstone on the project for TypeScript, it's like, hey, just give me a minute. I need to figure this out. Let me
Sure.
hear it.
Yeah, great. You can also get some things I don't use so much. You can get the output as JSON. You can pipe some of the type output into other tools if you wanted, for instance, reuse the type output for documentation. There's a couple of projects that do that auto-generate documentation from the types. You can coverage information. Yeah. There's some project called just documentation. Great name. That uses Flux and does a pretty good job with it. But overall, it works pretty well. All right, well, my voice is shot. It's been an hour and 5 minutes. I'm so sorry to all of you for making me sit through this. I hope that at least one of you enjoyed it. If not, I'll be drinking in the corner, okay?